Last year, over 52,000 Americans died from some form of drug poisoning.
That's nearly enough people to fill all of Yankee Stadium.
But there's one type of drug that impacts more than any other.
A drug that threatens the lives of more than 2 million Americans.
America is facing an epidemic of addiction to opioids.
Huge opioid epidemic.
The opioid epidemic.
The opioid crisis.
Opioid overdose.
Opioids are physically addictive.
We're going to spend a lot of time, a lot of effort, and a lot of money on the opioid crisis.
But what is an opioid? How does it work? And how did it become a national emergency?
An opioid is a drug that impacts nerve receptors to prevent the body from feeling pain. It comes from the seeds of the opium poppy, which is mostly grown in the Middle East and Asia. The top opium-producing countries are Afghanistan, Myanmar, and Mexico. Inside the seeds of the opium poppy is a milky fluid that contains morphine. This morphine is extracted and becomes the starting point for all other opioids. Drugs like heroin, oxycodone, hydrocodone, and fentanyl. Our focus is heroin, properly known as diamorphine. An odorless, white, crystalline powder, diamorphine was first introduced in the late 1800s as an alternative to morphine. For years, pharmacists tried to create a more powerful, less addictive version of morphine. One of its biggest problems was that once it was inside the bloodstream, morphine molecules were slow to dissolve across a layer of tissue called the blood-brain barrier and into the brain. This meant the drug was slow to set in, and by the time it did, it was less powerful. Scientists found a solution in altering morphine's polarity. Because the hydroxyl groups in morphine attract more electrons to one side of the molecule, they give that side a more negative charge than the other. These negatively charged poles cause morphine molecules to bond easily with oxygen. For this reason, when introduced to water or blood, morphine quickly dissolves, inhibiting its ability to cross the blood-brain barrier. The key was in preventing morphine from dissolving in water. Scientists found out that by replacing the hydroxyl groups with two acetyl groups, morphine is no longer polar. The charge becomes neutral on both sides, preventing it from bonding with oxygen and dissolving. It can then cross the blood-brain barrier and enter the brain. Once there, the added acetyl groups are broken down by enzymes and the remaining morphine can get to work. Because two acetyl groups are added, it is formally called diacetylmorphine, or diamorphine for short.
But how does diamorphine actually work?
When we feel pain, sensory receptors in our bodies are stimulated. These receptors send a signal across millions of nerve cells, or neurons, to reach the brain and spine. There, the message of pain is registered by the central nervous system. Neurons communicate with each other by transferring messages through chemical cues called neurotransmitters. The connections between neurons, called axons, have small gaps between each other known as synapses. Neurotransmitters are released by the receptors of one neuron and travel across these synapses to bond with the receptors of the next neuron. This cycle continues until reaching the central nervous system, acting as a sort of biological game of telephone. Diamorphine works essentially by interrupting the process. Your body uses natural suppressants called endorphins, short for endogenous morphines, to manage the feeling of pain. Diamorphine mimics these endorphins by its similar chemical composition, allowing it to easily bind to receptors in the endorphin's place. But because it is much more powerful, it blocks all transmission of pain and stimulates the release of dopamine, a neurotransmitter controlling pleasure. This causes a warm rush on top of diamorphine's overall numbing sensation. Receptors become overstimulated and desensitized to dopamine, making each successive high less potent than the last. Chronic users are forced to increase their dosage in hopes of achieving a high as powerful as their first in a process called chasing the dragon. The effects of diamorphine extend far beyond the initial high. After the dopamine rush, blood vessels dilate and force warm blood to the surface of the skin, prompting a warming sensation. In a matter of minutes, the body becomes severely dehydrated, dry mouth sets in, and the pupils constrict. Diamorphine also disrupts the body's ability to detect internal carbon dioxide levels. Breathing, heart rate, and blood flow all slow considerably. The muscles grow heavily relaxed, causing severe constipation and urinary retention. mental functions become clouded, leading to nausea, vomiting, and dizziness. The body eventually relaxes to a point of respiratory depression. Slowed breathing and blood flow prevent oxygen from circulating, and the lungs eventually shut down. Those who overdose suffer from asphyxiation or lack of oxygen and experience loss of consciousness, permanent coma, brain damage, or eventual death. All of this can occur in just a few minutes or a few hours, depending on the dose of diamorphine taken. When prescribed by a doctor, adult patients are normally given about 5 milligrams by injection or 10 milligrams orally every 4 hours. Beyond 10 milligrams, diamorphine becomes dangerous. A lethal dose is subject to individual tolerance, which is built over time based on frequency of use. For those who have never come in contact with diamorphine, a 20 milligram injection is enough to kill. For addicts who use heroin daily, they can handle as much as 200 milligrams in 24 hours. It's when addicts take a break, however, that their level of tolerance decreases. Usually when they come back to the drug, they overdose. In older patients with frail nervous systems, death has been known to occur after doses as low as 10 milligrams.
For this reason, diamorphine is a controversial analgesic for use in older patients or those nearing the end of life, as it has the capacity of accelerating death and is a prime drug for physician-assisted suicide. This is how Harold Shipman, a physician-turned-mass murderer, killed nearly 300 of his patients between 1978 and 1998. Shipman focused primarily on elderly care, especially that of women, but he had a peculiar pattern of old age patients dying while he was present or just after he had left. The truth was, Shipman had become addicted to murdering his patients by giving them high doses of diamorphine, slowing their heart rate to the point of asphyxiation. He would record their deaths as being from old age, heart attack, stroke, and other common fatalities, then steal jewelry and other valuables from their homes. It wasn't until he attempted to forge one of his longtime patients' wills that he was caught and evidence of his murders came to light. He was arrested and sentenced to life in prison. Thanks to advanced detection processes, murderers like Shipman can be easily caught now. Traces of diamorphine can be detected in samples of blood, saliva, urine, or hair through a process called liquid chromatography mass spectrometry. As long as there is a concentration of at least 1 nanogram of diamorphine per milliliter of a urine solution, it can be detected as far as 72 hours since initial exposure. Advances like this have put an end to the overprescription of opioids like diamorphine, holding doctors and patients more accountable for their actions. But over the last few years, addictions and overdoses have continued to be a problem in America. In 2015 alone, over 33,000 people died from opioid overdoses. So how and why did this become such a problem?
To understand the causes of the opioid epidemic, we have to rewind back to 1980. That year, a misleading study published in the New England Journal of Medicine led doctors to believe that opioids were safe and rarely addictive in medical use. As a result, opioid prescriptions skyrocketed. By the time brands like OxyContin and Percocet came about in the 1990s, nearly all doctors were on board with prescribing opioids. Between 1991 and 2011, the number of opioid prescriptions more than tripled. But slowly, the reality of patient addiction came into view. In 2007, Purdue Pharma was forced to pay fees of over $600 million for falsely advertising OxyContin as being less addictive than it was. Numerous doctors were prosecuted for overprescribing pain pills, and by 2012, the CDC recorded over 23,000 deaths from opioid overdose. The medical community quickly responded by decreasing the number of opioids prescribed to fight the epidemic, but it was too late. Those denied their prescriptions resorted to illegal opioids like heroin to feed their addiction. As a result, heroin overdoses have more than quadrupled since 2010. With nearly 13,000 deaths in 2015 alone, heroin has become America's poison.
It's no wonder that the opioid crisis has been declared a national emergency. It kills more people every year than car accidents or gun violence.
With so many people dependent on the amazing powers of these drugs, more and more Americans are dying from its misuse. Diamorphine, oxycodone, and other opioids were developed to help people live their lives, not take life away from them.
But it seems no matter what we try to do to limit the availability of opioids, Americans are bent on poisoning themselves with them.
We won't find a solution by focusing on the drugs themselves. we have to try focusing on the people who are being poisoned by them. Because if we can't change Americans, opioids like diamorphine will.